Let's talk about linear pairs and vertical angles. You might remember in our previous video lesson that we talked about something called opposite rays, and they're going to be a much bigger deal in today's lesson compared to the previous one. Recall that opposite rays are rays that share an endpoint and head in opposite directions, like ray AR, which starts at point A and heads to the left, and ray AY, which starts also at point A but heads to the right. Recall also that we learned about adjacent angles, like angle ABD and angle DBE, the purple one and the blue one. They're adjacent because they share vertex B and side BD. In other words, they're touching, or they're next to each other. Whereas non-adjacent angles are something like angle ABD and EBC, the purple angle and the orange angle. They only share a vertex, not a side, so that makes them non-adjacent. So if we combine the ideas of opposite rays and adjacent angles, we get something called a linear pair. Two angles are a linear pair if they are adjacent and if their non-common sides are opposite rays. So in this diagram, angle ABD, the purple one, and angle DBC, the blue one, they form a linear pair. And the reason is because, first off, they're adjacent. These two angles share side BD and vertex B. And also, they're formed from opposite rays. Ray BA and ray BC are opposite. They both start at B, but one goes off to the left, the other goes off to the right. Points A, B, and C are collinear. In other words, they all lie on the same line. That's actually why this is called a linear pair. Do you see the word line in the word linear? It's because these are two angles built off of a line. And as you might have guessed just by looking at the diagram and knowing what we know from the previous lesson, linear pairs are always supplementary. Because they're built from this straight line or straight angle, that means they have to add up to 180 degrees. In other words, they have to be supplementary. So let's work on identifying linear pairs from a diagram. Name an angle that forms a linear pair with angle VXW. VXW is this one right here. And in order to form a linear pair, the angles have to be adjacent, and their non-common sides must be opposite rays. In other words, really what you're looking for is a straight line with two angles built off of it. So for this angle, if I continue both of their sides, like if I continue side VX off in the other direction, there's no opposite ray out here, because this one bends up and off in the other direction. These 3 points are not collinear. But if I look at this side, so if I continue this side of angle VXW off in the other direction, yeah, this is all collinear. These are opposite rays. XW and XY, those are opposite rays. So that means that angle VXY forms a linear pair with angle VXW. These two angles are adjacent because they share ray XV as one of their sides, and their non-common sides are XW and XY, which are opposite rays. Next, I want you to find an angle that forms a linear pair with angle YXZ. So again, it's the same idea. You're looking for a straight line, and it's the same straight line as before. These 3 points are the collinear points in this diagram, W, X, and Y. So looking at this straight line, there's this ray that comes off of it, ray XZ. On the other side of it is angle WXZ. So these two angles, angle WXZ and angle YXZ, they form a linear pair because they share a side, ray XZ, that makes them adjacent, and because their non-common sides, XW and XY, are opposite rays. Next question. If the measure of angle WXZ, that's this little angle right here, is 78 degrees, then what's the measure of angle YXZ? Well, we just said that these two angles form a linear pair, right? That's the last answer that we just had. So if they're a linear pair, that means that they have to be supplementary. And supplementary means they add up to 180 degrees. So if one part of this linear pair is 78 degrees, what do I need to add to it to get to a total of 180? The answer would be 102. The measure of angle YXZ would have to be 102, because I know that angle YXZ and WXZ have to add up to 180 degrees, because they're supplementary, because they're a linear pair. True or false? Angle VXY and angle YXZ add up to 180 degrees. True or false? If you said false, you answered correctly. These two angles do not form a linear pair because XV and XZ are not opposite rays. These two angles are adjacent, but because their non-common sides are not opposite rays, we know that these two angles are not a linear pair. And if they're not a linear pair, then we can't assume that their sum is 180. Okay, so that's linear pairs. Let's talk about vertical angles. Vertical angles are non-adjacent angles formed by the intersection of two lines. For example, in this diagram, these two purple angles, angle EFI and angle HFG, they're vertical angles because these two lines intersect, line EG and line HI intersect at point F. So these two angles were formed by intersecting lines. And they're the non-adjacent angles formed by the intersecting lines. Remember, non-adjacent means that they can't share a side. All they share is a vertex. Vertical angles are cool because their angle measures are equal to each other. So whatever the measure of angle EFI is, the measure of angle HFG would be the same thing. There's actually another pair of vertical angles in this diagram. There's actually always two pairs of vertical angles created by the intersection of two lines. These orange angles would also be vertical angles. Angle EFH and angle IFG are vertical angles as well, because they are non-adjacent angles formed by two intersecting lines, so that means that these two angles would have the same measure as well. Relating back to the linear pairs that we just learned about, each pair of purple and orange that you see in this diagram would be a linear pair. This purple angle and this orange angle are a linear pair because they are adjacent, they share this side, and because their non-common sides are opposite rays. Same thing with this pair of purple and orange, and this pair of purple and orange, and this pair of purple and orange. So in every diagram that features two intersecting lines like this, you'll have two pairs of vertical angles, those are the non-adjacent ones, and you'll have four linear pairs, these two, and these two, and these two, and these two. You'll see that in every diagram that has two intersecting lines. So let's give it a try. Do you see two pairs of vertical angles in this diagram? They are angle JMI and angle KML, the two acute angles. That's the first pair of vertical angles. The other one is angle JMK and angle IML. That's another pair. These two obtuse angles are vertical as well. Okay, well if I know the measure of angle JMI is 39 degrees, then what's the measure of angle KML? Also 39 degrees. Since they're vertical angles, their measures must be equal. Again, assuming that angle JMI measures 39 degrees, what's the measure of angle IML? Is it also 39 degrees? No, because these two angles aren't vertical angles, they're a linear pair. Linear pairs are supplementary, which means they add up to 180 degrees. So I would be able to assume that the measure of angle IML is 141, because that's what I add to 39 to get to a total of 180. So what we're seeing here is that if you have a diagram that features two intersecting lines, like this one, you're actually able to calculate all four angle measures as long as you know one of them. So since I know the measure of angle DAE is 82, I can also assume that the measure of angle CAB is 82, because those are vertical angles. But I can also figure out the other two angles in this diagram, because they form a linear pair with the original 82-degree angle. Since these two angles are a linear pair, that means they add up to 180. And since these two angles are a linear pair, they add up to 180. So I can say something like this: 82 plus the measure of angle CAD is 180, which means CAD is 98. And by the same line of reasoning, we can say that the measure of angle BAE is 98. Or you could have also said that because this is 98 and these two are vertical angles, that's another reason that these two would have to be equal. Let's use our knowledge of vertical angles and linear pairs in an algebraic context. First question you need to answer for yourself on a diagram like this is, what kind of angles have been labeled? Are they vertical angles, or are they a linear pair? These are vertical angles because they're non-adjacent. They're on opposite sides of the intersecting lines. These two angles only share a vertex, no sides. So since these are vertical angles, I can set their expressions equal to each other and solve. I'll subtract 7x, add 42, divide by 4, and I get x equals 13. So I can plug 13 in to either of these expressions and simplify to get an answer of 101 degrees for both of these angles. And now that I know that both of these are 101, I can calculate the measures of the other two angles as well, because each of these form a linear pair with one of the angles that we just calculated. So like the measure of angle GFH and the measure of angle GFJ, those two angle measurements would have to add up to 180 because they're a linear pair and linear pairs are supplementary. So what do I add to 101 to get to a total of 180? 79. So GFJ would be 79 and so would HFI. On our next diagram we see two angles marked with algebraic expressions, but this time they're a linear pair. They're adjacent angles because they share a side and because their non-common sides are opposite rays. So since these are a linear pair, that means that they are supplementary and add up to 180 degrees. So I will say 14x plus 17x minus 6 is equal to 180 degrees. Combine like terms, add 6, divide by 31, and then plug 6 back in to figure out the measure of angle MKN, which would also be the measure of angle LKP, and plug 6 in here to figure out the measure of angle NKP, which would also be the measure of angle MKL. And that's all you need to know about linear pairs and vertical angles. In our next lesson, we'll explore all of the angle relationships we've learned about in this lesson when they've all been combined together in the same diagram.